students, in chapter 5, we will be learning about continuity and differentiability. We already have the knowledge of limits. We learnt it last year, and so we know the definitions of limits, etc. In continuation to that, we will be learning the concept of continuity. As the word suggests, continuity is for functions. So actually, very rawly put, continuity of a function, if you can draw the graph of a function without lifting the pen, okay? Say for example, if you have the function f of x is equal to x square, what kind of a function is this? This is a quadratic function. It is a quadratic polynomial, and this represents graphically a parabola which is open upwards. So f of x is equal to x square will be a parabola which is open upwards, and it will be having its vertex at the origin. Okay, so when you draw this curve, you can see that you can draw the curve without actually lifting the pen. So if you can do so, then you can say such a function is continuous. This is a very raw definition of continuity. We have to link limits and continuity and understand what continuity means mathematically. Now let me write a function f of x, it is equal to 1 when x is greater than or equal to 0, it is equal to minus 2 when x is less than 0. So now I have defined a function which is equal to 1 when x takes 0 or positive values, and it takes the value minus 2 when x is negative. Now how do we plot the graph of this function? We have for x greater than or equal to 0, the value of the function is equal to 1. So at x is equal to 0, the value is 1, and for all values of x greater than 0, the function will assume the value equal to 1. For all values of x less than 0, that is when x take all negative values, the function is going to take the value minus 2. Now we will put a hollow circle, because at x is equal to 0, the value of the function is 1, where we have put a thick circle, and at x is equal to, and so we have to exclude this point, that is at x is equal to 0, and only show the graph of the function for values less than 0. So this is for x less than 0, the value of the function is minus 2, and for this f of x is equal to 1. So now what can you say about the right hand and the left hand limits of this function? For example, take the right hand limit at around x is equal to 0. So for all points greater than x is equal to 0, the value of the function is equal to 1. For all points where x is less than 0, the value of the function is equal to minus 2, which implies the right hand limit about x is equal to 0, which is equal to 1, is not equal to the left hand limit of the function at x is equal to 0, that is f of x here takes the value minus 2, that is the left hand limit and the right hand limit of this function does not coincide. Since the limits do not coincide, the limit does not exist at x is equal to 0, alright, and also we say that the function is not continuous. Now why is the function not continuous? Obviously when you draw the graph of this function, you will draw from here till here, that is you will intersect the y-axis at minus 2 for all negative values of x, and then without lifting the pen, you can't be drawing a vertical line like this. So without lifting the pen, it is impossible to draw the graph of this function, which obviously means that the function is not continuous. So this is the mathematical definition of continuity. So at a point x is equal to 0, if you want the function to be continuous, then the left hand limit and the right hand limit should coincide, which means that the limit of the function at that point must exist, and also the value of the limit at that point, the value of the function at that point of the limit should be equal to the limit of the function. So that is the definition for continuity. So I will write the definition for continuity right now. So it is continuity of a function f of x at x is equal to c. Now how is this defined? You need the function to be continuous at x is equal to c, which means the value of the function at x is equal to c should coincide with the value of the left hand limit and the right hand limit, or the value of the limit of the function at that point x is equal to c. So if you have limit x tends to c, f of x is equal to f of c, then you say that the function is continuous at the point x is equal to c. Now you can extend the definition of continuity at a point to the entire domain of the function. So if you see that the function is continuous at every point in the domain of the function, then the function is said to be continuous by itself. So you will be just stretching this definition, where at x is equal to c we are defining that limit x tends to c, f of x should be equal to f of c. If for all c that belongs to the domain of the function, this definition of continuity is satisfied, then you can say that the function f of x is continuous everywhere in the domain of the function. I hope this is clear to you. So this is the continuity of a function f of x at x is equal to c, and generally continuity of a function everywhere in the domain means that the function will be continuous at all points x is equal to c belonging to the domain of the function.